Hello, and happy snow day to everybody. I just wanted to go over, since we weren't going to have a chance to go over this today in class, I just wanted to make a quick video to kind of take you guys through the answers on the page for calculating speed, velocity, and acceleration. We're going to start off with each section one at a time. We're going to go with the defining the following terms. So we'll start with velocity. We've gone over these quite a few times. Numbers 4 and 5 are a bit new, but you should be able to understand them pretty easily. Velocity, of course, is the speed and direction of a moving object. If we're talking about constant speed, this is referring to the rate of change of position in which the same distance is traveled every second. I'm going to shorten distance to D is traveled every, and I'm going to shorten second to S. Every second can be referred to as a unit of time. It can be every minute, every hour, etc. Acceleration is a measure of the change in velocity. This is, of course, over a period of time. I'm just going to shorten time to T. Forces in motion, we're going to be abbreviating some of these terms. Some of the abbreviations would be distance. I'll actually do this in red. It'll be distance. We have seconds, which would be abbreviated to S. And we have time, that would be abbreviated to T. With positive and negative acceleration, think of it like this. If I have an object, let's call it object A. Object A is going forward with a velocity of 5 meters per second. Object B is also going forward with the same velocity, 5 meters per second. In this example, both objects are going to the right, which is a positive direction. In this example, I'm going to represent velocity with a black line, and I'm going to represent forces applied with a red line. Object A is applied a force on it of 5 newtons in the same direction that its velocity is also traveling. Object B has a force applied to it 5 newtons, but in the opposite direction that it is traveling. In this example, object A is going to accelerate in the same direction of its velocity, and it's going to speed up. This is a positive acceleration. Object B, however, is going to see an acceleration in the negative direction because the force applied is pushing it in this direction. It will have the acceleration of its velocity. This will make it slow down, or in these terms, give it a negative acceleration. I've already given you the answers to numbers 6, 7, and 8. However, I do want to go over these with you in this video. I would have gone over them with you in class, and we can touch on them a little bit tomorrow as well. With speed, the formula is simply distance divided by time. Remember, if you're ever in a bind and you really need to remember exactly what it is, speed is just like any version of speed you ever heard of. For example, when you're driving your car, you're going miles per hour. Mile is a unit of distance, and hour is a unit of time. Therefore, we know that the formula for speed is distance divided by time. Velocity, as we've gone over with the definition, is going to be speed, but with a direction attached. So for example, if I was going to be going with my distance over time formula, I also have to attach a direction as well. So we can just put plus direction on the end of that formula. The formula itself is just this part, as long as you know that direction has to be added on for velocity. Acceleration is a little different than the previous two. The formula for acceleration is going to be the change in velocity divided by the amount of time you're recording it. So the easiest way to find the change in velocity is to take the final velocity, or VF, for final velocity, and subtract the initial velocity, or starting velocity. I'm going to say VI for initial velocity, initial meaning the starting. We divide that by the amount of time that has taken place. Let's take a look at an example for this. Let's say that you're driving in a car, and when you first start measuring your acceleration, you're traveling at a rate of 10 meters per second. At the end of the time that you're measuring your acceleration, you're traveling 20 meters per second. The time it took for you to get from 10 meters per second to 20 meters per second was a time of 10 seconds. What does that mean for our formula? What we're going to do is we're going to take the 20 meters per second, and we're going to take it over here as our final velocity. Because remember the formula, VF minus VI divided by T. So we have our final velocity, which is 20 meters per second, and we have our initial velocity, which was 10 meters per second. My initial velocity subtracted from my final velocity, and then we're going to take that and divide it by the amount of time, which was 10 seconds. 20 meters per second minus 10 meters per second equals 10 meters per second divided by 10 seconds, which means that we had an acceleration of 1 meter per second every second. What this means is that every single second, my car was accelerating with an increased velocity of 1 meter per second added, which kind of brings true to the formula. When you take a look, we now have 1 meter per second every second. This unit is also found here if you take a look there, which also kind of brings true to what I was saying earlier when I said the unit will typically be found in the answer. If we look at numbers 9 and 10, it can all be determined based on what you put in the x and y axis. We know that speed is going to be distance divided by time. Since time is typically going to be in the x-axis, we can go ahead and put time here. We know that it also involves distance, so there we go. We put it in the y-axis. If we have an average speed, it can simply be a line like this. That is showing an average steady speed from the beginning to the end because you're traveling the same amount of distance over the same amount of time. Over with a positive acceleration is implying that we are speeding up. So if we put distance over time again, we can make this line be increasing in the slope as it travels along the x. The rest of the problems on this particular worksheet are showing you that you can take word problems and you can extract the information you need to plug them into the formula. This is going to be a simple plug and chug activity. For example, number 11 says, a bowling ball travels down a 30-meter alley in 2.5 seconds. What is its average speed? Well, we know that average speed is going to involve distance and time, where we have a distance right here as 30 meters, and we have time with 2.5 seconds. We know that the formula that we could use for distance and time will be speed with d divided by t. So we're going to take our distance, we're going to divide it by our time, and in this case, it's going to be 30 meters divided by 2.5 seconds. When you take 30 and divide it by 2.5, we get 12 meters per second. This would be our answer. Number 12 brings a bit of geography into the mix. We know that Akron is in Ohio, and we know that Pittsburgh is in Pennsylvania. Pennsylvania is out to the east, so we know that our direction going from Akron to Pennsylvania will be east. Let's figure out exactly what the speed of the plane is. Number 12 says that a plane travels from Akron 116.25 kilometers to Pittsburgh in 0.75 hours. What is our velocity? Velocity, as we know, is also going to be dividing distance by time. The only difference between the speed and the velocity then is that we're going to be adding a direction for final answer. What we need to do is take our distance, which is 116.25 kilometers, and divide it by 0.75 hours. It's important to make sure that you are really making sure to consciously keep your units. I purposely left my kilometers and I purposely left my hours because those are going to be going into our unit in the answer. I move this over to the side just a little bit, and then I can go ahead and take out my calculator and divide 116.25. Take that and divide it by 0.75. So I have 116.25 kilometers divided by 0.75 hours, giving me 155. That means that my answer is going to be 155 kilometers per hour east. I have to include east in my answer because this is velocity. Number 13 is taking the same basic idea because number 13 says a cruise ship travels from California to Hawaii, a distance of 2,600 646 miles in 63 hours. What is the ship's velocity? We have, again, a problem that involves velocity, meaning distance divided by time with a direction. So we have distance. In this case, it is going to be 2,646 miles all over 63 hours. Something to keep in mind for this problem is that Hawaii is southwest of California. All right, so what we need to do now is go ahead and take out our calculator. Through the last problem, and I'm going to type in 2,646 and divide it by 63. 2,646 miles in 63 hours gives us 42, meaning that our answer will be 42 miles per hour southwest. This is the full answer, and you have to make sure that you include the direction when it is asking you for a velocity. Number 14 says that the approximate distance from Lodi to Cleveland is 56.25 kilometers. A motorcyclist completes the trip in 1.5 hours. What is the average speed? Notice that in this problem, it is asking for speed, which means it is not asking for velocity. It is asking for just the speed. You do not have to include the direction in this case. The answer for number 14 can be solved as such. It is another speed problem. It is distance divided by time. Distance in this case being 56.25 kilometers. Divided by our time, which is 1.5 hours. And all we need left to do is solve the problem. We've plugged in the numbers. Now we just have to chug it along. We have, clear the previous one, 56.25 kilometers divided by 1.5 hours gives us 37.5. That means that our answer will be 37.5 kilometers per hour. I am keeping the exact same units from the problem, and I'm transferring it down into the answer. Number 15 starts to bring the idea of critical thinking to all of this. It says that from a red traffic light, a car accelerates to 56 kilometers per hour in 8 seconds. What is its rate of acceleration? It starts off by giving you the equation again. Acceleration equals the final velocity minus the beginning velocity divided by t. You can say beginning velocity, initial velocity, or starting velocity because they all mean exactly the same thing. In this case, there is no clear number given to us for the starting velocity. However, if we read the question, it says from a red traffic light, which tells us that the car was starting from 0. This is what I'm talking about when I say it's not a complicated question. If you know that a car starts from red light, you know that it starts from 0 in any speed. So it says from this red traffic light, a car accelerates to 56 kilometers per hour. That 56 kilometers per hour is going to be our final velocity. So we'll take that 56 kilometers per hour, and we will subtract our initial or starting or beginning velocity. In this case, was 0 kilometers per hour. We take that and we divide it all by the amount of time in which this problem takes place. in this example, it took place in 8 seconds. So we'll bring our 8 seconds down here. Finally, we go ahead and bring out our calculator, clear the previous problem. We have 56 minus 0 gives us 56. I hope you all kind of realize that and you think to yourself, wow, what did Mr. Paradise do to just waste time? We take that 56 and then divide it by 8 seconds to give us 7. That 7 means that we have an acceleration of 7 meters per second per second. The car added 7 meters per second per velocity every second from the beginning of the problem. Number 16 is asking you, is number 14 a positive or negative acceleration? This is actually a slight typo. It should say, is number 15 a positive or negative acceleration? Since the number 15 problem is talking about a forward direction and a forward increase in speed, we can say that it is a positive acceleration. Number 17 is changing it up just a little bit. It says that a truck traveling along I-76 at 65 miles per hour, it comes upon a wreck where he has to slow down to 33.5 miles per hour in only 6.3 seconds. What is the rate of deceleration? What we have to look for again is remember that acceleration equals the final velocity minus the initial velocity divided by time. We have all 3 of these necessary in the problem, but you have to be very careful to make sure that you pick out the right ones for each variable. In this particular case, it says that he is traveling at 65 miles per hour. This will be our initial velocity. He says that later on, he has to slow down to 33.5 miles per hour, which will be our final velocity. This all occurs in the span of 6.3 seconds, which will be our time. So when we plug and chug with this particular problem, we have to keep all of our numbers along with correct variables, which means we're going to take 33.5 miles per hour, and we're going to subtract 65 miles per hour. We're going to take all of that, and we're going to divide it by 6.3 seconds. Let's take out our calculators. We plugged in the numbers. Let's chug them along. Clear the previous problem. We go 33.5 miles per hour, and we subtract 65 miles per hour. I know that this is a negative number, but remember, we are slowing down, so our velocity should be going down, which means our acceleration will be a negative number. We take this negative 31.5 and we divide it by 6.3. This gives us negative 5, which means that the answer is going to be 6.5 I'm sorry. 5 meters per second per second. It's asking you, should be 17. Is 17 a positive or negative acceleration? it is a negative acceleration because you are decreasing the speed. Once again, number 19 is asking you to be thinking a little bit critically. It says a room 26.6 meters wide as a fly does from one side to the other in 7 seconds. What is the fly's speed? You do not need to know the direction because it's a speed, not velocity. We need to know distance divided by time. Our distance in this case will be 26.6 meters, and our time will be 7 seconds. We can plug in the numbers. So we have 26.6 meters divided by 7 seconds. With our calculators at the ready, we take 26.6 meters divided by 7 seconds to give us 3.8 meters per second. And finally, number 20. A bicyclist is traveling at 4.5 meters per second. He starts down a 100-meter hill, and in 2.5 seconds, at the end of the hill, she is traveling 17 meters per second. What is her rate of acceleration? We have a problem involving acceleration, which means we have to bring back the formula. Acceleration equals the final velocity minus the initial velocity divided by the time. In this case, our final velocity is 17 meters per second. Our initial velocity is 4.5 meters per second. And our time is 2.5 seconds. We can take these numbers and we can use plug and chug, which means that her acceleration will be 17 meters per second minus 4.5 meters per second, all divided by 2.5 seconds. What we need to do next is go ahead and get out our calculators. We will take our 17, subtract 4.5 to give us 12.5, and divide that by 2.5. The acceleration that she experienced was 5 meters per second per second. If you have any questions at all about any of these problems, please comment on the link posted on Google Classroom. Once again, I hope you're having a fantastic snow day, and I will see you all tomorrow.